Welcome. Today what we're going to be doing, I'm going to give you a demonstration on plastic welding. I am going to explain what type of tool we use for plastic welding. I'll explain to you why we can plastic weld. But the main thing with this little skills task is reading the drawing. What we'll find, this will probably be the simplest drawing you guys are ever going to get in your life. And I guarantee if you do not read it correctly, you will make a mistake. So the main marks will this be on the accuracy. Okay. What we'll do when you hand these in for assessment, we'll be checking the accuracy, whether you've got the right welding rod in the right position, you've got the right thickness material. This is what we'll be mainly looking at, not necessarily the weld, because we realise it's very difficult to have the skills to weld after one easy lesson. Okay. Now you've all had a look at that drawing. Yeah. Now can you see, you all understand the drawing? What about that M1 on the end of it? You all understand what that is? No. So you've made a mistake straight away, haven't you? Okay, you haven't read the drawing. This is what the whole idea of this is about. That M1 means machining. Right? So I want you to go on your drawing, it's got M1 on one end, I want you to write that on the other end as well, so it's machined on both ends. And what do we do when we're going to machine something? What do we have to do? We have to make it longer, don't we? So that measurement there of 75 will now become 80. Can you understand what I'm saying about reading the drawing? You understand what that 2 by 2 is? That 2 by 4? No? That is the type of welding rods we use. In plastic welding, the welding rod is designated by the end section. Okay, now have a look at the end sections on that. There's a 3mm and a 4mm fillet. Okay, you can pass that around, have a look at that. And you'll see what I mean. What else does it say that we've got to be looking at? Big black writing there. Scrape radius corners. Did you just pick that up? Right, so what that means, we have to round all the corners on this, on the material before we actually put it together. Now to do that, it's pretty simple. All we need to do is use the edge of the rule. This is one time where we can use a tool for what it's not designed for, because this is hardened steel, that is soft plastic, it's not going to damage the rule. So just a scraping, just be careful that you do not get carried away by scraping in the centre, because you'll take too much off in the centre and not on the edges. Okay, just scrape both sides of it, make a nice little round there. If you want to go a little bit further, you can use a little bit of wet and dry and give that a good sand up for your wet and dry. Yes? Righto. There's another thing we've got to look for before we start. On the back of your plastic, on all plastics that you buy, it has a protective film. Please make sure you remove the plastic film before you start welding. That will be on both of them, on the little ribs, as well as your base plate. Looks like that's off that. Yep, that's off. Now, because there's a protective film on there, that will leave a little bit of grease, okay, contaminant on your surface. So where you're going to weld, just get a little bit of wet and dry paper and give that a bit of a clean up. Okay, on both sides. Yep. All right, we're ready with that? Okay, now we'll just put that aside and I'll just go through the OH&S of our plastic welding. Righto. Now, do you remember your school days? The two different types of plastics? Yes? What were they? Thermoplastics and thermosetting. Yep. Your thermoplastics are like what? An example. Like your PVC, your acrylics, polypropylenes, ABSs, okay? They're all what they call thermosoftening. Your thermosets are more like what? Your Bakelite, your fiberglass resins. Once they're cured chemically, and when they're cured, they just do not move anymore. Righto? But with your thermosoftening plastics, we can heat it, bend it, heat it, bend it. It has a memory. Okay? Why can we do that? You remember from our chemistry days of our valency bonds with the atoms? Okay? It has a long chain valency bond. So that means with a small amount of heat, okay, we can bend it, reheat it, bend it back again. And that enables us, with a small amount of heat, to be able to fuse two bits of material together with a welding rod. So we don't need a great deal of heat like we do when we're stick welding. In stick welding, what are we getting the temperature up to? About a bit over 2,000 degrees C. With plastic welding, we're looking around about 350 degrees C. So that's the reason why we can plastic weld. Now another thing we've got to remember when we're plastic welding, if we're going to weld PVC, we must use a PVC welding rod. If we're going to weld ABS, it must be an ABS welding rod. There's only one exception to that rule, and that's with your acrylic. Okay? Most people call it Perspex. Perspex a trade name. You can use PVC to weld acrylic. Okay, that's the only exception. Now, all your plastics, they are exceptionally toxic. When I burn PVC, okay, it will let off a gas, okay, it'll smell of hydrochloric acid, which is quite toxic. So, if you're unsure of your material, you can check what it is by a simple burn test. Now there's charts like this around, okay, that gives you where the material is used, what the heat setting of your gun is, okay, and what the burn test is on the side there. Now for an example, your PVC, okay, when I burn it, it's self-extinguishing yellow smoky flame and a strong smell of hydrochloric acid. Okay, so we'll just do a little burn test here so I can show you. I just got a tray there with water in it, so if any drips, it's going to drip into the water. Okay, so the yellow flame, black smoke, self-extinguishing, right, and that does smell of hydrochloric acid. Okay, did anybody get a whiff of that? No. No, well I don't really want you breathing it, but okay, it's not good. But you can do a burn test. Okay, now if I wanted to do ABS, it burns with an orange flame. Okay, there's soot flakes that come off it. It's similar to the acetylene and has a strong sweet smell when it's extinguished. So you can do a burn test and that will tell you what type of plastic it is you're trying to weld. Now in this industry, they use a lot of plastics on your motorbikes, flarings, okay, in cars. How much percentage of a motor vehicle these days do you think this is plastic? Yeah, that's a huge amount, probably 30-40%. Okay. So what they do in the automotive trade, if they're unsure of what the plastics are, because a lot of the plastics come from overseas, they'll cut a little bit of scrap piece off the back of a part that's got to be welded, that's not structural, and they can use that material as their welding rod. So it doesn't have to be a manufactured welding rod, as long as it's the same type of material. There is exceptions to that rule. A lot of your plastics have fillers in it. Okay, sometimes they put nylon, sometimes they put fiberglass, carbon fibre in it. If it has a filler in it, you cannot plastic weld it. So it has its limitations. We've got any questions on that? So that's just basically why we can plastic weld. Now I'm quite sure you guys in the engineering field, you're going to come across it. Okay, when we were looking for the CNC overhead router, we got onto a site down Sydney. They had 5 of them. an engineering firm, but just doing plastics. Okay, so it is huge. They are everywhere. Right, now the machine that we use, or the tool that we use, is a heat gun. Now what the heat gun is, okay, it has an electric motor. It has a fan and a heating element. The electric motor drives the fan, which forces air over the heating element, then it comes through this restricting nozzle at the end of it. This will get up to about 600 degrees C when I put it on maximum. We'll put it on about 350 degrees, which is number 8 setting. Okay, number 8 setting we'll be putting that on. There is your on-off settings on the back there. We'll be putting it on number 2. All right, that's your speed of the fan. If I was working outside, I'd put it on a higher fan setting, but number 2 on the inside is fine. All right. Now, when it goes through the front section here, that gets extremely hot. Extremely hot. If I was to put my hand on that, my hand would stick to it, okay, when it's hot. Right. Now, I've gone through, I've explained the process, what we're doing. I've explained the machine that we're using, or the tool that we're using. What is the hazard of that tool? Yeah. What other hazards have we? Electricity. Excellent. Okay. What else?
It's a bulky tool. It's like a big tool.
Big tool. Cumbersome. Yeah. Yeah. Put it all down. This is all your H&S of it. What else? The material that we're using, what happens if we get the wrong setting and we burn it? It's going to catch on fire, and then what's going to happen? Fumes. So, what have we got to make sure of?
We're wearing a mask.
That you wear a mask. We've got good ventilation. We've got the exhaust fans up there that we will turn on when we're doing this. Okay, and we've got good ventilation. And wear your P2 dust mask. But we don't want to burn it, do we? Okay, so how can we manage that? I'm just going to jump ahead a little bit here. How can we manage that so we don't burn it and create fumes? Make sure we have the correct temperature and correct technique. Is right with that? You got any questions? What are some of the things we've got to check with before we start welding or turn the machine on? Check the cord. Make sure it has the safety tag on there. Okay, which it has. It's been dated. So we know this is good for the next 12 months. What else would we check?
There's no obvious damage to the machine.
No obvious damage. No cuts on the cord. The pins are not bent. Make sure that the lead is not going to be on the ground to become a trip hazard. What else would we check? Make sure we've got no flammable material around before we start welding. Extremely important. Make sure we weld on a full space. Okay, a scrap piece of material. This is what we'll weld on. Because these benches, they've got varnish on it and they can catch on fire. Got any questions?
Isn't that still like dangerous until you only got like a 300-degree gun onto a piece of wood?
I'm only going to 350. Okay, and technique. Okay, making sure we got the correct. It is dangerous, my word, it is. Okay, but it's better than having metal, because the metal's going to heat up on you and you're going to burn yourself. But with the correct technique, okay, and keeping the gun at the right setting, we should be fine. Okay, the only way that's going to catch on fire, I was to stand there like that. Okay, which it would do. That's why when we finish with the gun, we stand it upright, like so. All right. So that's all part of your management tool. So we'll bring that up on the management. Okay, so we've identified all the hazards. So what are the risks? We've done the risks. Yeah, burns, fumes, Electrocution. Trip hazards. Anything else?
Entanglement in the cord.
Entanglements in the cord, yes, definitely, good one. Yep. So your management tools. What are our management tools?
Communication.
Communication, definitely, always communication. Correct setting of the gun so we don't burn the material. We only plasticise it. Remember that word? That's all we're doing. We're only plasticising it. What else? What other management tools? Ventilation, PPE, a P2 dust mask. These are the welding rods we're using. Okay, can you see that? What have we got there? What? There- Poke in the eye, so that would be what? A projectile. A projectile.
Would eye embedment be the same?
Yes, eye embedment. So what do we do? How do we manage that? Cut it in half. Simple. We've managed the problem. Make the welding rod smaller, manageable. Any other management tools? Make sure you do a bit of research before you start welding. Okay, make sure you get the correct heat setting. Make sure you got the correct rod. Make sure you clamp all material. Okay, underline that. Make sure you clamp all material before you start welding. You'll see when I start doing the demonstration how difficult it is if you don't clamp it. Of course, we have to have downward pressure and we have to move the welding rod along. So it's important that it's clamped in place. Got any questions so far? Righto. We'll go on to the next phase. What we're going to do now, we'll do the marking. Now you've got your drawing there. What would be the first mark we'd put on that drawing? What would be the first measurement or mark? The centre line. Okay, centre line. So you can do that either one or two ways. We can use our rule, come in 25mm either side, mark. We can send our jelly calipers up to 25mm, which I prefer. The reason why I like these is straight away we've got to check. We know we're right. Okay, turn it over both ways and you know you're right. So you do that, make sure you flip your job over and come back from the same side. Don't go the opposite side. All right, we've got two centre lines there. Yep. What's the next measurement we'd put on there? Where the two webs go. So what measurement would I put on the base plate? What measurement am I looking for? How much? 15. That would give us the centre of that web, wouldn't it? So that's going to be very difficult to line up. So wouldn't it be better to come from the edge? Yes. So what measurement is that?
3 mil thing, so it'll be 16 and a half in the middle.
16 and a half?
Or 13 and a half. Depends which side you want to go.
13 and a half, yeah. I'd go 13 and a half the inside. Okay. You see how he's done that? Okay, you've got your centre line, you've got your 3mm webs, you take 1.5mm off each web, that'll make it 27, half of 27 is 13 and a half. All right, so you set your dividers up to 13 and a half. So what I do with that, I always double check, go over, flip over, 27. I know I'm right. So you can mark. Come back down, mark the bottom. We can mark both sides. Just remember our technique with our scriber. You always hold the scriber on just a little bit of an angle. Why is that? You know why that is? You hold it upright because of the shape of the scriber. It's on an incline. Okay, it's going to hit on the edge there, and you're not going to get the point of the scriber hitting right on the edge. You understand what I mean? Like that, it's going to go right on the edge. Up there, it's going to miss the edge of the rule. Keep your fingers out the way. Okay, the other side. Okay, we've got that marked? Yep. I'm ready to go. Ready to start welding? Seems like it. What did I do first before I started welding? What's one of the golden rules in the workshop? Measure twice, cut once. Check it. Okay, we know. 25, 27, 25, 27. I know that's right. Now what I have done, what you'll need to do, you'll need to have these little scrap pieces on either end, because when you're plastic welding, it's extremely difficult to start the weld off. I'll give you a demonstration in a minute. I'll show you why. So what we do, that wasn't a mobile phone, was it? It's in the office here, is it? Okay, we put these scrap pieces of material on either end. We can start our weld off on the scrap piece. By the time we get up to our parent material, we have a good cut. All right. Now what I've also got made up, we've got these little plastic welding jigs. Okay, they're made at 27 mil for you. So they'll fit on there. And then we get our clamp. We can clamp it in place. We'll check it. And those little strips go on the edge like so. Righto. Now it's going to be impossible to hold that, hold our rod, hold our gun and do it all in one go. So what we do, just move this out the way. We have what we call a tacking tip. These sit on the gun, like so. When you look at your gun, that straight section is in line with your eye. Can you understand that? Yep. Okay, that's got to fit in there like that. Don't pick it up because it's going to be hot, it's going to be used. Okay? When you're here, there's going to be people are going to be coming and going all the time. That will be hot. Make sure you use pliers. And when you finish with it, what do? Okay, because you're going to have to take it off. It's going to be hot. Finish with it. Remember the heat box? Hot. You can even time it if you want to. Okay? Because, as I say, people are going to be coming and going. And what's another method that we can use to make sure people don't touch it?
Put a sticker on it or something?
Yeah, we've done that. Communication. Okay? Guys, that's hot. Do not touch it. How do you check something if it's hot?
You put a bit of paper next to it and see if it burns?
Possibly. Okay? Back of your hand. Back of your hand. Right? Back of your hand. You'll feel that heat come off. Not the front of your hand. because you lose a lot of your sensitivity because that's the part of your hand you're using. The back of your hand is more sensitive. Okay, you put your hand there and you'll actually feel the heat coming off without touching it. Any questions? Right. Now we can plug this in. Now guys, what I'll get you to do, I'm going to set up two of these guns down this end, two the guns down the other end, because they draw a fair bit of amperage. If we have the 4 guns running down here, they trip the circuit. Okay, so we'll have 2 guns operating down here, 2 guns operating down the other end of the room on a different circuit. Right, now the setting for this, can you remember what the setting was? 8. And the fan setting, 2. And then that takes a couple of seconds to heat up. Now to check it, if it's hot, just put your hand up and bring it down. Bring it down slowly. Okay, just a little feel, just come down slowly, put your hand up there and come down. Can you feel that heat coming off? Right. Now you have to be careful with this gun. There is not only heat coming out of there, there is heat coming out of the restriction nozzle. Okay, we have to do that because it will have too much back pressure in the gun and damage the gun if we don't have that heat coming out of that little restriction nozzle part there. All right, it's just releasing the pressure a little bit. So be careful that there is heat coming out there as well as the top. Now the technique, this is only a tacking tool. Okay, there's no mechanical strength to this at all. All it's designed for is an aid. It is only holding the material in place while we're welding. It's only an aid. So what I'll do, line it up, keep my fingers out the way. I'll do a little tack on the end. Try to come across onto your sacrificial piece because it'll help hold it there. You can see I'm just using another tool just to hold it in place so I don't burn myself. And that's tacked. The same on the other side. Little tack on the end. And you see the technique. That was at 45 degrees. At 45 degrees. Okay, and just slowly along. Not at 90 degrees, at 45 degrees. What we can do now. Okay, our little jig. This will then go on the edge to hold it so our hands aren't in the way. And we tack the inside. Very important that you tack both surfaces, guys. Turn it around and you can do the other side. Right, now that's just held it. Now as I say, there's no strength to that at all. Take our tacking tip off. Put in our heat box. Right. Our spacer goes back in there to hold it. And then we can clamp back onto our spacer, like so. Yep. Now before I start, I like to do a little test run just to make sure that I've got the right heat setting. Right. Now with your fillet rod, okay, the fillet rod is shaped like so. Okay, it's like a triangle. So that triangle is designed to fit in there like so. You with me with that? So that triangle fits in there like so. Now, I'll just show you the technique. Okay, this is the welding gun, this scriber, just for the sake of the demonstration. Now what I'm doing, I'm directing, okay, 60% or 40% of the heat at the fillet rod, right at the base there. Not up there, right at the base. 40% of the heat there, 60% of the heat onto our parent material. So what I have to do, I have to preheat as I'm going along. So it's what they call pendulum welding. It's a pendulum motion, like so. Okay? Do not heat up there because you'll plasticize your welding rod and it'll just bend like a little bit of wet spaghetti. So 60-40, 40% at the tip, 60% on your parent material. The welding, that will be held at 45 degrees. Not up there, not down there, at 45 degrees. And also at 90 degrees to your material. 45 degrees and 90 degrees. Not at an angle, not at an angle. You right with that? Okay, now with the plastic welding, what we do, we have to preheat our parent material first, whereas on our main job, we don't have to because we've already done that with our tacking. So I preheat the tip. This is why we have a sacrificial piece to start off with, because you'll see how difficult it is to start the weld. Remember the 60-40? I'm preheating as I'm going along. See how it's very difficult to start off? And you'll see that little bit of a wave in the front. Okay, about a kilo of pressure, but as I say, I'm putting quite a bit of pressure on that. When you have a look, you'll see a little wave on the front and a little wave either side. Now that started to burn there, so I'll just move the gun away. Now your PVC plastic is the hardest one to weld with because it burns. The other plastics won't burn, they'll only plasticize. So your technique is critical when you're welding PVC. Now when you look, you'll just see a little bit of a bow wave there and there. Now you see the burn marks? Okay, they're not a problem. The problem is if you have to weld over that. Okay, it becomes like an inclusion. It's like slag in a stick weld. So what you'll have to do, when that cools, you scrape that away. Okay, same as you scrape the slag away on a stick weld. Exactly the same. So that's got to be scraped away before you've got to weld over it again. All right. You never ever cool your plastic in water, okay, because you'll affect the physical strength of it. You must let it cool naturally. You can use air to cool it, but never water, because it's hydroscopic and it'll absorb moisture, okay, and it'll affect your properties of your material. Alright, so now we're ready to start welding on our job. You can cut that scrap piece off there if you want to. Always make sure you hold it down, because if you hold it out, that scrap piece can fly off. So hold it down towards your bench, use your pliers, cut it off. Right, now just preheat your tip just a little bit. I don't have to preheat my parent material because I've already done that by tacking it. Okay, pendulum motion. Downward pressure. Now the book says about 1 kilo downward pressure. How you'd work that out, I'd never know. But I'm putting quite a bit of pressure on that. Okay, and you'll see in the front of this weld, there's like a little bow wave. Okay, when I finish, let it cool for a second, give it a twist. Okay, preheat your tip. Ready to start welding. Pendulum motion, 60-40, downward pressure. The rod's at 90 degrees. I'm getting the bow wave. I now come over to my workpiece and the rod then goes to 45 degrees. Slight burn there, so I'll move the gun away. Take the rod off onto our sacrificial piece. Let it cool for a couple of seconds and just give it a twist. Okay. Now, remember me telling you about the plastics, how you heat it up and they plasticise. That's one of the disadvantages with your plastic welding. Look how that's plasticised. Right. If I was to bend that over there like that and let it cool, it'd stay like it. So technically, every time you do a weld in plastic welding, you should let it cool before you do your next weld. But we haven't got enough time to do that. So what you can do, you can just hold the rule against the side of it, let it cool a little bit. Okay, but don't quench it in water. So that's one of the big problems with your plastic welding, plasticizing. I don't know, we got that welded? Now this is why we have these sacrificial pieces on each end. This will now become a little clamping device that I can hold my work in place. And the next one is the 2mm. Well, what do I do with that before I start welding? Cut it in half. Now this is a lot smaller rod, so it's going to plasticise a lot quicker. So you'll have to be just a little bit quicker with your welding. Once again, it's up at 90 degrees. I'm getting the bow wave. I get to my workpiece, over at 45 degrees. Now remember at the start of it, I said this is a test. Basically, in reading the drawing, you'll be surprised the amount of students that will put the wrong weld on the wrong side by not reading the drawing. So make sure you follow what the drawing says. Downward pressure. It's at 90 degrees. I've got the bow wave. When I get to my workpiece, over at 45 degrees. I'll just make a little mistake here, just so I can show you. Now what I've done, I've taken the heat away. And if you can see in there, there's no bow wave. no bow wave. There's a bow wave all the way along there, but there's no bow wave. That would be a failure. Once again, that's all plasticized. Technically, we should let that cool and then we do the back welding because it's going to get too much heat in there. And as soon as it starts getting too much heat in there, what's going to happen? It's going to burn, isn't it? We're getting close to its combustion temperature. So, and also, do not clamp your job when it's soft, because what's going to happen, it's going to put a dent in there, isn't it, because it's plasticized. That's why we clamp on our sacrificial piece. Got to prepare our welding rod, cut the worst piece off the bottom of it. Right. Now, one other little thing I want to tell you. When you're welding, that length of your job is exactly the amount of welding rod you're going to use. Okay? You don't cut that off to that length, do you? Because by the time you get to the end, you're going to burn the tips of your finger off. Okay? So, if we don't have the correct technique, stretch it when we're welding. Remember I told you it has a memory. It's going to want to shrink back and it's going to break and put undue tension into your workpiece. Right, I'll do one correctly, then I'll do one where I stretch it, and you'll see what I mean. I'll do this one correctly. This one's at 90 degrees all the way. We don't turn this one over at 45 degrees. Now you can see how that's starting to get a bit hot. See how it's starting to burn? Come off onto your sacrificial piece. Give it a twist. Now this is what happens if you don't have the correct technique and you start stretching your rod. Okay, we start off. I've got a good weld. Everything's going fine. It's at 90 degrees. It's not burning. That's welding very good there. Wrong technique. See how I've bent that over? Now you can see just by the shape of that how it's all distorted. It's put tension into it. Okay? Totally wrong technique. Sometimes they'll actually crack and spring back. Okay, they'll actually crack. Where this one hasn't. But you can see how it's gone all thin compared to the one on the other side there. Alright, so make sure you keep your rod up at 90 degrees and don't put tension in it. Yeah, see that's starting to crack there now. Okay, it's starting to spring back from that little section there. Now see that's plasticized. See how it's all plasticized? So what you do, okay, leave your little template in there, your little jig, let it cool, then it'll stay in that shape. Okay, when you finish, you can hold them in the vise and cut your sacrificial pieces off with a hacksaw. We got any questions on that? Right, now one other thing I want you to remember. When you are finished with your welding gun, do not turn it off. I want you to turn it down to 0 and let it cool down. Okay? Because what happens if you turn it off straight away, okay, you haven't got air blowing over your heating elements. Okay, what they are, the little round wires in there, they're going to contract too quickly and they can break. So let it cool down. It'll never get 100% cool. Okay, it'll never get 100%. It'll take about 3 or 4 minutes for it to cool, and then you can turn it off. When we finish our housekeeping, make sure we pack everything up. Okay, get rid of all the scrap pieces. Okay, because they are flammable, put them in a rubbish bin. Tell people around you that the gun is on, that your tacking tip is hot. And that's it. Okay, we got any questions on that? No? Just remember, the exercise is reading the drawing. Make sure you get the right thickness material, the right type of rods. Okay, because that's what we'll be marking you on.